So this one will be Mills versus MOA. So we just finished up the first little shoot to hunt, like 3-day half class, and all these points came out again, as they always do. Um, so mill radians versus minutes of angle. Both are an angular measurement. That is, they span an arc, right? They're not linear. Do not use them as linear. If you use them as linear, you are compromising the speed and ease of using the system, the correct way to do it. With both of them, you have a ruler when you have a reticle 3.5 inches from your eye. You don't need to reference the target and try to translate inches to MOA or mils. The ruler's right in front of your face. Use the ruler. So the ruler can be in anything. It's just known points on a scale. It could be inches or MOA. It could be mils. It could be parsecs. It could be light years. It could be 7 lengths of a banana. It doesn't matter. All of those systems are used as an angular increment. Okay. So I'm going to reference field shooting. What I mean by field shooting is hunting or practical use that involves smallish targets. So, 10 to 12 inches or smaller. Target plus time. So time is a factor and stress is a factor. Add on to that changing positions or odd positions. So not a PRS match where you clip into a tripod or you shoot from a game changer on a barricade. There's nothing wrong with that, but it's a contrived, and it cannot matter in that. Field shooting as in hunting animals that move in a chaotic, stressful situation at times. So the first is advantage of MOA. If you do not translate linear measurement inches into your brain and then try to calculate how many MOA that is, there are none. There are no advantages to MOA when it comes to shooting quickly and accurately, coming up with drop data or elevation data and wind data. Unfortunately, for whatever reason, MOA doesn't translate into a consistent pattern at range, and I'll explain what I mean by that here in a minute. Advantage of mils. Well, first, it's a base 10 system. So mils they're used in the metric system. They're not metric. A mil is just 1/1000th of any distance. So a mil is 1 yard. It spans visually 1 yard at 1,000 yards, 1 inch at 1,000 inches, 1 meter at 1,000 meters, 1 parsec at 1,000 parsecs. Okay. So we kind of, when you think mils versus MOA, and I'll use one of my guns. So we'll just do something simple. Well, that one's pulled up, so we'll do that. So I'm using I'll just use a 6.5 Creedmoor. Everybody loves that. I think I'm doing it just to upset people. I'm using a 6.5 Creedmoor at 5,000 foot DA, and I've got 2650 feet per second muzzle velocity. Okay, so the first thing, I'm going to kind of skip ahead, but it's easier to think and say decimals than it is quarters. So if we go to 435 yards, so first off, with this Creedmoor, without even looking at the drop, 435 is 2.4 mils elevation. Okay, so if I go to 435, it's 2.3 mils. There we go. So we'll talk about that. 2.3 mils, but it's 7.9 MOA or 8 MOA to round up. So if we look at 400, It's 2 mils. Well, that's 6.75 MOA. Let's look at 500. It's 3 mils or 9.75 MOA. 600. 3.8 mils, or correction, 4 mils, 13.25 MOA. So what you see is there's a consistent pattern to using mils, and that is what we call quick drop. So quick drop on an average gun, 6.5 Creedmoor generally, 223s with heavier bullets, 308s, 30-06s, things like that. So 2550-ish to 2800 feet per second muzzle velocity, and normal BCs of 0.4 to 0.6 something or 0.7 is the range. So the range, take 2 off the first number, and the last 2 numbers become the decibel. So 300 is 1 mil, 400 is 2 mil, 500 is 3 mil, 600 is 4 mil. What that means is that the range and the decibel gives you the answer for the drop. So 530, take 2 off the first, that's 3.3. 490, 2.9. 610, 4.1. And if it's a 0.5, it's 15 yards or whatever, you round up to the nearest number. So this works really well for a lot of guns. And then there's a correction factor that's very easy to add into that for almost all guns that allows you to do this in your head without looking at any app or anything else. But the reason it's super helpful is because it means every 10 yards, the bullet is dropping 1/10 of a mil. So it's linear. It's linear in this sense that it's consistent. So when I go in 100-yard increments, generally it's 100, or in 100-yard increments, it's generally 1 mil change. Whereas in MOA, there's no real consistent answer there. It doesn't follow that path. Why? I don't know. Jesus loves 10s, I guess. But with, I won't say all guns, almost all guns, there's a correction factor that makes quick drop in your head really fast, quick, and super easy. So I don't need my calculator. I have yet to meet an MOA shooter that can tell me what his drop is for 319 yards, 427, 498, 586, 612, right? On demand. And yet it takes us about, using quick drop in this, it takes guys about 3 or 4 minutes, 5 minutes to grasp this concept, and then they can do it on demand. And they can give you their data within 1/10 of a mil of what it should be, or what it actually is, within 4 to 5 seconds or less, within an hour. So that's one big benefit of mils, is that it follows our trajectory for most rounds, most cartridges and bullets very well. So Jesus loves 10s. Wind brackets. So a wind bracket is the same for every gun. It's a wind, a full value wind at a certain mile per hour that drifts this specific bullet, whatever that bullet is, 0.1 mils per 100 yards. So X mile per hour full value wind drifts 0.1 at 100, 0.2 at 200, 0.3 at 300, 0.4 at 400, 0.5 at 500, 0.6 at 600. And that's true for all combos. The only thing that changes is, okay, so the only thing that changes is how much wind in mile per hour it takes for the different bullets. So for this combo, a 6.5 Creedmoor with a 147 grain ELDM, that's a G1BC of 0.697 approximately. It's usually, in most conditions, a 7 mile an hour gun. So what that means is a 7 mile an hour full value wind, so straight left to right or right to left, will drift that bullet 0.1 mils per 100 yards. This works, wind brackets work for almost all guns to about 600, some 700, some 8, There's correction factors, but 600 to 700 yards, this is where it is. And it's relatively easy to learn to use the wind bracket system. So, this isn't going to go into it. You really need to be in person, or you need some visual aids to grasp this, but it's very simple math that can be done in your head relatively quickly, like sub 10 seconds on a target. A 223 with 77 grain TMKs is a 4 mile an hour gun. So when you're looking at your wind bracket, it's, for most combos, it's just the first number of the G1BC. So if it's a 0.4 G1BC, it's a 4 mile an hour wind bracket. If it's a 0.5 G1C, it's a 5 mile an hour gun. So it'll 5 mile an hour full value wind will drift you 0.1 mils per 100 yards. Now, if you go super high in velocity, or you go way up in density altitude, or you go way low, etc., that can change 1 or 2 miles an hour, but it's really easy in an app. Set the app to 600 yards, change the mile per hour wind speed at 90 degrees until it says 0.6, and then check at 400, check at 700, and you're done. You know your wind bracket for the gun. Now, so that's very easy to teach. Doing this in MOA, there's no clean way to do it in MOA. There are some workarounds, but when you actually write the steps out on paper, it's 2 to 3 times longer and much more complicated in to do. And in your head, it's very complicated, relatively speaking. And I shoot MOA every couple of years. I'll shoot MOA for 4 or 5, 6 months exclusively, just to get comfortable with the system. And I'm trying to win and perform at the same level I am with Mills, same time, same standards. And yet, no matter what I do, it takes me twice as long. And that's just for wind. Elevation is a complete non-starter. So let's look at what we have to do. There's a couple of ways to do it with MOA. None of them are good, but the general way that I do is, and I think that I've seen the best results from MOA shooters, is set it to 500 yards and find the full value wind that drifts at half an MOA per 100 yards. So in this example, with a 6.5 at 2650 feet per second muzzle velocity with a 147 grain ELDM at 500 yards, a 2 mile an hour wind drifts 0.5 MOA. At 400, that same 2 mile an hour wind drifts 0.4 MOA. At 300, it drifts 0.3 MOA. So we're drifting, pun intended, a bit from baseline. At 600, it drifts 0.6 MOA. At 700, it drifts 0.7. So you can see that it's that is drifting. You can use the base system of, it's drifting half MOA per 100 yards with some flex in there, some error on either side, or you can say the 2 mile an hour wind is drifting X point MOA per 100 yards. So in this case, I could say it's drifting that amount of MOA per 100 yards. So 300 is a 2 mile an hour wind at 300 is drifting 0.3 MOA. At 400, it's 0.4 MOA. At 500, it's 0.5. At 6 is 0.6 MOA, etc. The issue here becomes it's a real small number. So at 400, it's 0.4. I've got an 8 mile an hour wind. That goes 4 times. That's 1.6 MOA. But now I have to convert that into something I can use, which is 1.5 MOA, generally 1.25 MOA or 1.75 MOA quarters, because it's not a point system. So yes, there's a version for using MOA with wind brackets, but it's extremely convoluted. It's not clean, and it's not concise, and it's much harder to do in your head on the fly under stress. And that's the biggest difference with all of these. There was a couple of people in the last week or two that really thought they could do the MOA. It was no problem. Elevation and the windage was no problem in their head, right up until you put them on a timer, and then the whole thing came apart. It's much different sitting at your table going, well, this is what it should be, than it is in the moment, trying to get in position and do it. And in those scenarios, mills are much quicker and much more precise with a lot less error that happens. The other big difference is in the reticle usage. So if you draw out a reticle and you think about it, in a common mill reticle with 0.5 mils per tick mark, so half mil hash reticle, it's extremely easy. Actually, with every mill reticle that's based in tens, it's extremely easy to interpolate the distance between two known points to a 10th mil. So even with a 1 mil per dot reticle, it's very easy to just point to where 0.7 should be, or 0.3 or 0.5. With half mil hash reticle, it's even easier. You can interpolate between 0.5 mil and 1 mil where 0.8 would be. In a quarter-based system, this is harder for two reasons. One, most MOA reticles are 2 MOA per tick. Okay, so you got 2 minutes of angle per tick mark in the reticle. So now let's say we want 6.75. So I draw out 6.75 and I have a tick mark at 6 MOA and I have a tick mark at 8 MOA. So now visually I have to draw a line in my mind. I have to see where 7 MOA would be. So I break it in half. Then from that half, from 6 MOA to 7 MOA, I have to break that down into quarters. Again, adding steps here. So if that was a mil reticle, I could just go to 0.4 on the reticle. But with MOA, I've got to go, okay, the top line is 6 MOA, the bottom line is 8 MOA. Mark the reticle in my mind's eye, if you will, at 7 MOA, and then break it down into quarters. And it works this way through the full reticle. There's at least one, if not two, separate steps that has to be taken visually and mentally with an MOA reticle system that mills doesn't have. Having said that, if MOA was based, so you had a MOA reticle where it was 1 MOA per tick, and the turret system was in 0.1 MOA per click, then you could use it exactly like a mill reticle in this instance. You could go, hey, it's 6.7 MOA. From 6 to 7 MOA, you can figure out where 0.7 is very quickly. Unfortunately, that's not how the system works. It's a quarter-based system. Yet we shoot in a 10-based system. Hundreds of yards is a 10-based system. So when you have shooters being taught optimum with both systems, the ones using mills have fewer errors, they're faster, they are more precise with less screw-ups. That's at flat range, stressful situations, and hunting. Mills offers advantages that MOA does not give us. Or if it does, it's extremely convoluted to get there. And what you see is everybody just puts their face in an app and pulls up their Kestrel or looks in their app to do it. With mills, you don't need that. This year alone, I think we're at like 3 or 4 animals this spring that have been killed with guys that we've taught using quick drop and wind brackets without pulling their app up, without pulling their data up at all, out to a little past 400. So this is just a quick overview. It's kind of convoluted. I haven't had enough coffee, but when we look at mills versus MOA, they are the same as regard to they are both an angular measurement. However, they are not the same in use. Their performance, when you lay technique A versus technique B and you test enough people using both techniques, one of those techniques is going to come out to have a higher success rate. That is more accurate and faster. They're not going to come out 50-50. In this case, mills comes out way higher in field shooting than MOA, using the same shooters, trained to the same standard and practiced to a high level, all the way from a high level to an extremely low level, base level. They're not the same in use. In use, in field shooting, mills are quicker, more precise, with fewer screw-ups. They offer us quick drop from our head that MOA does not, and they offer us a much cleaner way to use wind brackets without having to use an app. Okay. It's a really long subject that's hard to do in 15 to 20 minutes, but if we have any more questions on that, I guess ask.